Myself, Dr. Prashant Kumar Gautam, Professor, Department of Mechanical Engineering, GIS College of Engineering, Pollani. Advanced Welding Technology, ME 7038, lecture number 30, Welding Inspection and Testing Methods. Welding Inspection and Testing Methods. So, after welding, it has to be tested to check the quality of the material to a welding area so that it can be serviceable. And there are several methods out there to check the welding specimen. AWS section 9 will guide us the testing methods. What is weld testing? Methods of weld testing and analysis are used to assure the quality and correctness of the weld after it is completed. This term generally refers to testing and analysis focused on the quality and strength of the weld. Why to test the weld? To ensure development of quality weld by collecting qualitative and quantitative data. Qualitative data, that is non-destructive testing test, and quantitative, that is hardness, tensile, strength, ductility, toughness, fracture, toughness, etc. to be checked. To assess the suitability of welding for specific application. How to test the weld? Stages of inspection: before welding, during welding, after welding, testing technique, destructive, non-destructive. In this class, we will discuss about the destructive testing. Before welding, that is surface oxides, grease and oils to be removed. That is, one is cleaning, another is edge preparation. Edge preparation, number two, edge preparation. Dimension and quality of edge to be checked, whether it is a V shape, U shape, that is degree, we have to check the degree also. Backing of electrodes, etc. That means in electrode, flux coated electrode, there may be some moisture. Moisture should be removed. Removal of moisture from electrode coating. So there are several types of electrodes, and moisture is to be taken care to heat the electrodes. That is E6010 and E6011 ambient temperature is not required, but 6012, 6013, 7014 and 7024, this requires some ambient degree 100 to 150 degree Celsius, or centigrade also, 100 degrees centigrade. This is another low alloy, low hydrogen electrode. This is required, oven temperature is required 225 to 300 degrees Fahrenheit. These are electrode to be in a small oven, it should be dried. So welding will be better quality. During welding, selection of input parameters like current, voltage, welding speed, sealing gases, heat sources, temperature, etc. It has to be selected. So too much heat also will give some. So selection of temperature and this current, voltage is very important. That we have discussed earlier also. This current, voltage, welding speed, gases, coating of electrodes. These are heat source parameters. These are to be checked. This is welding current and deposition rate. This is current increases. There are several type of diameter of electrodes. How the amperage is fixed money. This rate should be increases. The current increases, this rate should be increases. This is the different current versus deposition rate. Current is 100 ampere, so low ampere, low. This is and this is speed is increases, current increases. This is excess. Some defects are there. So this current, voltage, welding speed, sealing gases, heat source temperature, etc. to be checked, to be preset after welding. Removal of slack. In welding, there is a manual metal arc welding. There is a slack is there. So this slack has to be in the top surface of the welding. So it has to be removed by ball peen hammer. This is pin, ball pin, and this is the check, neck, striking force. So this stress pinning is a stress removal slack by this hammer, and post-weld treatment by the drill structure and stress removal. Slack creates problem in multi-pass welding. This is post-weld heat treatment. So after welding, there is some stresses are there due to heat, so that has to be removed. The post-weld heat treatment by this stresses can be removed. After above decreases in temperature for refinement of grain structure in has. So this has to be removed by this coiling is there. So we can do the remove the stresses. The stresses to remove the stresses basically is 700, 760 to 770 degrees centigrade is given for relieving the stresses. So above decreases in temperature. So after the slow cooling is there. So stresses are removed. Well testing, that destructive testing and non-destructive testing. In this chapter today, we will discuss about the destructive physical damage to workpieces and welded joint. Quantitative data obtained by the destructive testing and non-destructive testing without physically damaging the workpiece and joint. Qualitative data is obtained. Destructive testing, weld test. Destructive test, some sorts of damage takes place in the component which is being tested. The extent of damage may be more or less, but most of the time it is observed that that component which has been tested by the destructive test is damaged to such an extent that it cannot be used for targeted application. These can be divided into two parts: test capable of being performed in the workshop and laboratory test, microscopy and macroscopy, chemical corrosive. This is defects occur during welding, which affects the quality and hardness of the plate. Other defects occurs through lack of knowledge of and skill of the welder and for the training of the welder. Type of destructive test, weld testing, tensile test, bend test. This can be done in the workshop. Hardness test, toughness test, and fatigue behavior. This is laboratory testing. Tensile test is used to check how the weld joint will perform under tensile loading and under different environment. Modulus of elasticity, yield strength, ultimate strength, kind of the deformation at the different stages, and the total elongation of the weld joints till the fracture. most simple and common method. This is a has this portion, so we have to this portion has to be cut, or this section to be cut, and to check the tensile. This is the weld portion, and this is the base material. So we can see the checking the how the joint is there, how the joint is performed. Another testing, maybe this portion is to cut and to check the weld quality. These are the two testing. Tensile test results must be supported by stress strain diagram indicating elasticity, yield strength, and ultimate strength, tensile strength, etc. These are the graph, tensile stress strain graph, and the base metal is the this this is the base metal. This is the base metal, and this is the gas tungsten arc welding by arc welding. This is green color is flux core arc welding. SMAW is the this portion, right? And this is saw submerged arc welding. These are the system diagram. This is another system diagram. Specimen of this neck portion. Specimen is cut, and the test system diagram is there. Specimen, different specimen. This the base metal is there. This is the base metal, and other welding tool is there. So we can check how the welding performance, what are the strength of the welding. Number two, all weld metal specimens. Means what I have told, this is this portion, all weld. This portion is cut, and we have tested the all weld metal. Determine the tensile property of the specimen that consists entirely of weld metal. The test specimen is oriented parallel to the weld axis and is machined entirely from the weld metal. There are two reasons for performing all weld and all weld test: to qualify a filler metal or determine the properties of the weld metal in a particular weldment. The following are typically properties that are measured and reported in an all-weld metal tension test: tensile strength, yield strength, and elongation. These are the specimen. This is 10 millimeter reduced section. This is 60 millimeter. This is the radius, 15 radius, 40 millimeter, plus minus 1 millimeter. This is the diameter, is 10 millimeter. This is the length. This is the so all well metal test specimen. Bend test. Bend test is one of the most important and commonly used destructive test to determine the ductility, soundness of the weld joints in terms of porosity, inclusion, penetration, and other macro size weld discontinuities. The outside of the bend is extensively plastically deformed so that any defects in or embeddlement of the material will be revealed by the premature failure of the coupon. So, when test, we can see the ductility, soundness of the welding joints in terms of porosity, inclusion, penetration, other macro size weld discontinuities. Type of bend test. There is a freehand, free bend test between two power supports. The weld joints is placed and then the compressive load is applied. For the bending to take place cheaper, this is specimen, this is preparation, this is bend test by compressive force, this is the bend test. So through bend test, we can see the quality of the weld, ductility, soundness of the weld. Guided bend. This is the base, this is the root bend, face bend. This is a, you can see the bend test. Loading, load keep on increasing until crack starts appearing on face or root. Angle of bend is considered as measure of ductility. That is, we can check the ductility and the defects in the bend. This is the bend test. This is, we can check the material how the welding is done. Welding is done. Hardness test. It is resistance to indentation or penetration, usually referred as a measure of resistance to abrasion and scratch. Due to application of heat in welding, materials like hard enamel, steels, cast cast iron, cast iron, steel, cast iron are subject to hardening, with, whereas material like aluminum alloy participation enable become softer. Hardness testing has to be taken here. Due to application of heat, welding and material like hardenable steel, cast iron are subject to hardening. So it has to be checked the hardness also. Hardening and softening phenomena usually occurs at has heat affected zone. The hardness test is very simple test. It is done. It is gives a lot of information about that if any microstructural formation has taken place or any embezzlement has taken place due to the application of the Weld thermal cycle. Toughness test. Toughness is the ability of material to resist both fracture and deformation. Toughness test simulates service conditions often encountered by components of the system used in transportation, agriculture, and construction equipment. Can be determined by calculating energy absorbed by materials before fracture. So, ability of material to resist both fracture and deformation. Method of toughness testing, that is Sharpie impact test, ISOT impact test. ISOT test, toughness test, held vertically on anvil as cantilever, holding cantilever type notch face the pendulum. Number two, Sharpie, held horizontally on anvil as simply supported beam. Simply supported type and notch is opposite side of pendulum impact, not facing to pendulum. Sharpie impact test. Sharpie V-notch impact test is the most common fracture toughness test used by industry. A notch specimen is broken by a swinging pendulum, and the amount of energy required to break the specimen is recorded in full pounds and joules. This is determined by measuring how far the pendulum swing upward after it fractures the specimen. This is the specimen. This is the notch. This is the machine. This is the pendulum hammer. Specimen, and this is angle. End of swing. This is a scale. So it can be seen that, and low temperature, the material is more brittle and impact toughness is low. At high temperature, the material is more ductile and impact toughness is higher. The transition temperature is the boundary between brittle and ductile behavior, and this temperature is often an extremely important consideration in the selection of material. This is the fracture energy, and this is the temperature. Bearing metal and weld electrodes. These are the 6013 grade electrode is used. This is the specimen notch. This is a specimen. The 10 by 10 size specimen. This is a cross section. This length is 55. This is a stress strain diagram. This portion is called high carbon steel, strongest, and this is the medium carbon toughness, tough, and this is more ductile. This is low carbon steel. This is low carbon steel. Strain, stress. This is the curve. We can see the percentage of carbon increases, strongest, and this is decreases, more ductile. And middle portion is toughness. Iodic impact testing is generally carried out with the specimens at room temperature, since the time required to accurate place it in the machine allow the temperature to increase. This can introduce a significant error when conducting tests at various temperatures. This is the specimen. This is impact test specimen, this graph, and this is pendulum is striking this portion pendulum control lever. So impact testing machine. So energy radiant without. Fatigue test. This is a ASTM E466 standard for preparation specimen. Fatigue performance of a component can be determined by endurance limit, number of load cycles that joint can withstand. This is very important for checking the material of the specimen, welding to material, how it can withstand endurance limit. That is very important. Fatigue test must include type of loading, axial pulsating, reverse bending, or tension compression, stress ratio of axiom stress to axiom minimum stress to axiom stress, temperature and vacuum, corrosive, environment, ambient temperature, and type of sample. This is the type of sample. This is the sample 1, sample 2. The radius is changed. Typical dimension of the standard, specimen R 100 millimeter, width is 10.3 millimeter, thickness is 11 millimeter, gripping length is 50 millimeter. This gripping length is 50 millimeter. First step is to conduct tensile test for assessing the yield strength of specimen. For plotting stress to number of cycles curve, SN curve, fatigue test is conducted with maximum applied stress load corresponding to 0.9 times of yield strength to determine number of load cycles required for fracture. And in the same way, the test is repeated for at 0.85, zero point 0.8, 0.75, and zero point 0.7, etc. So first is 0.8 yield strength, and then with the 0.85, 0.8, 0.75, and 0.7. So many tests are carried out. This fatigue test. This is the SN curve. The SN curve describes the relation between the cyclic stress amplitude and number of cycles to failure. This is sometimes more than 10 to the power 6 cycles, and this is peak stress, ultimate stress. So cycles, number of cycles increases, so it is decreases. So I have to check the limit SN card. So this is the end of the physical testing of welding materials. So by this testing, we can judge the quality of the welding material. Thank you.